¿Qué tal? Soy Francisco Szymanski y vamos a hacer el quiz de la semana 9, en el que se nos presenta un diagrama algo así. Estamos en una inclinación. No se ve muy bien, perdón. En una inclinación con un bloque que está atado a una polea a otro bloque, y abajo de este bloque hay un resorte y este tiene un ángulo de 40 grados. Sabemos que M1 es igual a 20 y M2 es igual a 30 y K1 de ese resorte es de 150 newton por minuto. Y lo que se nos pregunta es que si este bloque lo que hace la persona en este dicho problema es que lo agarra, que es en inglés. I'm going to say it in English from here on out. I'm sorry that I started with Spanish and also in my last video. I'm sorry, but I'm dying with homework. So with this block, we pull it. They pull it backwards 20 centimeters, and that could be for us point A, and they want us to know what's the velocity that when it comes through the point that it was originally, and let's call that point B, and for both blocks. So let's say that this is also point B, and something like this will be point A. Oh, and the spring will be attached to the block. So what we do now is that we use the the law of momentum and conservation of energy. So what we want to know is if the potential energy plus the kinetic energy, both in point A, that it's the 20 centimeters backwards, and they are equal to potential energy in B plus kinetic energy in B, and that's where we want to know their velocities. So yeah, so let's see if they have what energies are they pulling from them. So in the first block, we are going to count point A as 0 and point B to be in a height of 20 centimeters. We're going to have to convert them in meters so that we have that. So let's see. For example, the block is M1 in point A going through gravitational potential energy. The answer is no, because I'm going to change marker. I'll be explaining it meanwhile. So it's because when we want to acknowledge the potential gravitational energy, the formula is mass times gravity times height, but as we are doing it in this example, for us to have it a lot easier, is that we use point A as 0, as height 0, so that mgh, if that h is 0, all of the system is going to be 0. So yeah, I'm going to see if this looks good. No, it doesn't. Well, I'm going to continue with this, so you can hear my explanation. So we know that there is no gravitational energy pulling through the block, from where we are looking at it. And but because the two blocks are arranged in with a string, we have to acknowledge both of their states because the forces applying to each of the blocks are are connected through that string. So what we will have to do is that we're going to have to add them in this example. So yeah, let's do it. So we know that there is no gravitational energy going through A, and we also know that there is, but we know that through M2 there's going to be gravitational energy because it's upwards from our origin. So let's have like mass 2 gravity times height in times height of 2 in A, plus the kinetic energy that is applying through the spring in block 2, that it's going to be half of the kx squared, and those are all of the energies in the first, because in point A, the first block is going through, it's not having any potential energy, any potential gravitational energy, and there's no spring, so it's going to be 0, and as if it's not released yet, it doesn't have any kinetic energy neither. So yeah, let's keep doing it. So now what we have to do is to figure out if in point B there's going to be uh, potential energy, and we know that that's true because both of them are, well, let's just keep with M1. So when M1 is at 20 centimeters, we can't just do with the 20 centimeters because we have to get the height that is from point 0 to the 20 centimeters in the slope. So my marker isn't doing anything, so I'm going to pause the video and find a new one. So I can't find any other markers, so oh yeah, I found one. So let's keep going. So now we know, yeah, what I was telling you is that we need to figure out the height from the origin to the 20 centimeters